Concrete, one of the most widely used materials of the world, has been used since the dawn of humanity.
In their race towards modernity, concrete has played a significant part. But did you ever wonder about the problems of producing so much concrete? Concrete's most hazardous material, cement, is responsible for around 8% of the world's carbon dioxide emissions. So we are here to propose an innovative concrete mixture that will have the lowest possible environmental impacts while improving durability. We will achieve this objective by partially replacing cement with supplementary cementitious materials.
Now, let's talk about our supplementary cementitious materials. One of the most prominent SCM, fly ash, is a byproduct of the coal power plant. Silica fume is another byproduct obtained from silicon metals and ferrosilicon alloys, and GGBS is the end product in the separation process of slag from the melted iron. When partially replaced with cement, these materials help to produce second generation of calcium silicate hydrate gel and impart durability in the concrete.
The optimization process has been conducted with two phases of the trial. First, we have used a 2385 kg per meter cube mixed design of concrete for two trial location scenarios. But due to lack of local resources, GGBS and silica fume has been selected from Calcutta, India, while the rest are selected from our local resources. The first trial was conducted with different percentages of coal fly ash, GGBS and silica fume. Analysis of the first phase of the trial shows a very small amount of silica fume increases the durability to a large extent rather than coal fly ash and GGBS. But increasing silica fume has a very adverse effect on the environment. For example, 30% coal fly ash and 10% GGBS, we have got durability score of 1.832 with environmental impact reduction 18.50% in location scenario 2. Whereas for 30% coal fly ash and 10% silica fume, we have got durability score of 6.37 with environmental impact reduction 7.50% in location scenario 2. Moreover, trial shows that waterway is the most environmental friendly mode of transportation than railway or roadway. Later on in the second phase, a similar 2385 kg per meter cube mixed design of concrete was selected, ignoring GGBS in both BCS and ACS. We are ignoring GGBS due to its scarcity as local material, moderate durability and high environmental impact characteristics. Therefore, we settled on our final locations, prioritizing relatively nearby local materials and waterway. The performance results of trials indicated that for coal fly ash 36% and silica fume 4%, it is possible to obtain maximum durable ecoconcrete with least environmental impact. Use of these sustainable materials provides us a service life score of 3.15 with an average environmental impact reduction of 15.4%.
Now, let's discuss about our concrete mixture in the base case scenario and alternate case scenario. In the base case scenario, we have used 425 kg OPC type 1 as a binder from Confidence Cement Factory, Cuetx. Sand of 835 kg as fine aggregates from Sunamganj, Sylhet. 955 kg stone chips as coarse aggregates from Bholaganj, Sylhet. And 170 kg tap water was used to maintain a water binder ratio of 0.4. Finally, a conventional concrete mixture of 2385 kg per meter cube with 75.1% of total aggregates has been selected. Later on, in the alternate case scenario, 40% OPC has been replaced. 153 kg per meter cube of coal fly ash has been collected from Paira Thermal Power Plant, Patuakhali, and silica fume of 17 kg per meter cube from Vista Chemicals, Kolkata. And finally, by adding sand, stone and water from the previously described locations, we have made the 2385 kg per meter cube sustainable ecoconcrete.
As we know, life cycle assessment helps us analyze the environmental impact of a material's entire life cycle, which includes its extraction, production, transportation and distribution. And after analyzing each material, we have found an average environmental impact reduction of 15.4% from the base case scenario to the alternate case scenario. Individually, it shows the highest amount of reduction is in global warming, followed by fossil fuel depletion and ozone depletion. The reduction has happened due to the partial replacement of coal fly ash and silica fume, as their production and transportation are less reliant on fossil fuels and emit significantly less carbon dioxide or any other harmful gases like chlorine or bromine. However, silica fume often has impurities like lead and chromium, and this may lead to a comparatively less environmental reduction in ecotoxicity and carcinogenic impact. But these can be justified with a massive increase in service life and an overall reduction of environmental impact.
This mixed design tries to impart the least amount of environmental impact without compromising durability. Our project will bring us one step closer to achieve sustainable development goals. It will ensure a resilient infrastructure resulting in a sustainable communities. It will utilize huge amounts of industrial byproducts, and finally, by reducing global warming and other environmental effects, it will be bold action against climate change. It's time for taking innovative steps in construction for the betterment of planet Earth.
So let's say yes to solution and no to pollution.